Alright, well, welcome back. I'm going to do another example. This is example number 2 of the trapezoidal rule. Once again, we're using 4 trapezoids. We want to figure out if it's going to be an over or underestimate of this. So without further ado, let's try this out. Alright, so what we have is right here, we have 1 over x. And 1 over x, we're going from 1 to 2, 1 to 2. And so if you have this 1 over x from 1 to 2, kind of looks like that. It's going to be very, 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 very small values. Alright, so we're going to 1, and we're going to 2 right here, and we're going to create 4 trapezoids on this interval right here. Okay, so looking at this, we know that trapezoids, to find the area of a trapezoid, is 1/2 the height times the sum of the bases, base 1 plus base 2. So if you just remember that, whenever you're trying to find trapezoids, we're going to do this. And so we're going to first find out what our height is. Our height, once again, is our delta x. Delta x is always going to be b minus a over n, the number of trapezoids. Our b, it is, looking at this integral, is 2. Our a is 1. And so we can take 2 minus 1 divided by 4, and we get 1/4. Okay, 1/4. So it's going to be divided into 1/4. All right. We got 1/4, 1/2. Very small. And we have this, and so you can see right here, we can draw this right there, and kind of see it. All right, these are the 4 different trapezoids. The concavity is concave down, and because it's concave down, we already know that this is going to be an overestimate, because you can see that our line is above it. If it was concave up, it would be an overestimate. So if it's concave up, it's going to be a underestimate, but if it's concave down, definitely going to be an overestimate in this case. Okay, so we got our heights, and now we're going to find our bases. Our bases are the heights when we get from this function right here. So f, we'll just say, is equal to 1 over x. And so to find the area of a trapezoid 1, we're going to go through and do this. So we have 1/2. We're going to have 1/4, which is our height. And now we're going to find our bases. We're going to plug in our first one, f of 1, which is the base of our first part of our trapezoid, and base 2 is going to be 1/4, all right, or 1 1/4. Okay, from there. So we're going to have f of, I'm just going to go 1.25. Okay, 1.25. All right, that's trapezoid 1. We're going to add that to our second trapezoid, trapezoid 2. So we're going to have 1/2, our height, which is 1/4, and we're going to have trapezoid 2, which is f of 1.25. plus f of, add another 1/4 to that, which would be f of 1.5. 1.5. Okay? So that's our trapezoid 2. We're going to add those two to the third trapezoid, which is right there. Our third trapezoid, 3. All right, we got 1/2. We have 1/4 is our height. We have f of 1.5, which is that right there. And then we also have to add it to f, add one more 1/4 to that, which is f of 1.75. Okay. We're going to go finally, our final trapezoid, trapezoid 4. Find that area, so it'll be 1/2 the height, which is 1/4. And then we have f of 1.75. And we're going to add that to our last base, which is the last end of our interval. And we put that right there. Okay. All right, so we have f of 1.75, f of 2. So from here, because these are all uniform, if you watched my past video, what we can do is we actually can separate these out. Maybe you had the formula and you already did that. That is cool. All right, but what you see is that each one of these, to make this easier, all right, we can make 1/2 times 1/4, which is 1/8. And so we're just going to factor that out. What we left over is f of 1, and we have 2 times f of 1.25, and this is coming from the formula that probably many of you might have in your notes. And then we have f of 1.5. We're going to be using that twice as well, from trapezoid 2 to trapezoid 3 here. And then we're going to take 2 times f of, well, we're going to use this one, all right, once again twice. So we have f of 1.75, all right, and then go plus f of 2, because we're not using that twice. Okay. From here, we're going to plug our values into, if you recall, f is actually equal to 1 over x. That is an integrand, and that's the value, that's the function we find the area beneath. And so, to estimate this value, We'll plug that in there, so we have 1 plus 2, and we'll have 1 divided by 1.25, which is going to give us 0.8. So we'll have 2 times 0.8, and then we'll have plus 2 times, if you take 1 divided by 1.5, all right, we'll have 2/3, all right, 2/3, or 0.6 repeating, which you get, and then we have 1 divided by 1.75, which is not really the nicest thing in the whole entire world. All right, and we probably can just do, 1.75 fourths, 7 fourths, so it'd be 4/7. All right, 4/7, and then we go to the next one, and then we have 2, which would be just 1/2 from there. From here, all right, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, perfect. All right, and now we're just going to simplify this puppy, and so we have 1/8. We'll have 1 plus 1.6, and we'll have 4/3 right here. We'll have 7ths right there, and we'll have 1/2. Put this in your calculator. 1/8. 1/2 there. All right. We go 1 plus 1.2, 1.6 plus 4/3 plus 8/7 plus 1/2, and then, all right, multiply that by 1/8. And what you should get is approximately, all right, 0.697 times 3 decimal places. Cool. Now, like I said before, this is actually an overestimate. This is an overestimate because it's concave down. All right. So now, and we can kind of compare that, all right, to the actual value. And if actually we're finding this, we know the integral from 1 to 2, and we have 1 over x dx. We know the antiderivative of 1 over x is actually equal to the natural log of x, and we can go there for 2, and what we have is natural log of 2 minus the natural log of 1, which is 0, and so we have our answer is natural log of 2. The natural log of 2, all right, is actually going to equal approximately 0.693, and you can see that, yes, this is still the overestimate of what our actual value is. All right. So, once again, using the trapezoidal rule, you could have found these areas individually and just added them together. That would also have been okay. All right. I teach my students, if you don't, worst comes to worst, just find the areas of trapezoids. That's all you got to do. Draw a little picture. You're good to go. Concave down, overestimate, concave up, underestimate, and there we have it. All right. I hope that helps you out. Have a good day, and God bless.